Okay. Okay, hello everyone, welcome back. All right, so good evening everyone. So today's plan is also similar to last few sessions itself. We will solve questions from JEE Mains itself. Okay, so let's wait for a while. Hi. Okay. So first we'll solve some problems from the April shift. Okay. This question I guess appeared in either the 6th April shift or maybe 5th. Hello everyone. Hi. Good evening. Okay, so this question we already discussed in one of the previous sessions. So this formula, which is the transverse magnification formula, it's pretty important in this case, right? In the spherical refraction case. So the refraction formula to write down the image distance, most of you would be knowing it, right? N2 by V minus N1 by U equals N2 minus N1 by R. So this formula almost everybody knows, but this magnification formula oftentimes people don't remember it, right? So it is N1 by N2 times V by U. So this formula is pretty important to keep in mind, okay? Now everything else is just standard, right? N2, everything else you would put with sign convention. Object distance would be minus 4R. R value, because it is to the right of the center, it will be put with plus sign. And yeah, everything else is standard. Okay, so this question, once you solve it, the answer will be the second option. Okay. So I'm not solving the questions once again because Nikhil, if we solve it, then it will take too much time, right? We have like a lot of questions to cover. I'll explain the concepts mainly. The answer will be over here, okay? It will be written over here, bottom right. You guys will get the PDF after the session, and you guys can solve it and recheck the answers, okay? I'll explain the concepts, because if I solve everything, it will take too much time, okay? I mean, there is nothing much in this question. The only thing is you have to put U as, so this is the optical center, so because the object is to the left, you will put it as minus 4R, and this radius of curvature, right, this term, because this is a convex surface, R lies to the right, right, so you will put R as plus R, and then you will solve for V, and then you will find the magnification, okay. Next, so this is a question on polarization. So unpolarized light with intensity I0 is incident on a polarizer, okay. So so when we have a polarizer and we have unpolarized light entering it, okay, once it gets processed by the polarizer, we will get polarized light, and the polarized light, the plane of oscillation will be parallel to the polarizing axis. But the important thing to remember is, if the the polarized, unpolarized light, if it has I0 intensity, after being processed by the polarizer, the intensity will be halved, I0 by 2. So this is the first step that you need to remember, and after that we will keep another polarizer, right? The question is, what is the angle between the axis of polarizer and analyzer, so that intensity of the emergent light becomes 3 I0 by 8, okay, becomes 3 I0 by 8. So this is given to us by Malus's law, right? So this light intensity, let's say this polarizer's axis is at an angle theta to this incident light. So the after being processed, the intensity becomes this intensity, which is I naught by 2 times cos squared theta, right? So this is standard theory. So this we want it to be equal to 3 I naught by 8. So from here cos theta is 3 by 4, or theta is 30 degrees, right? Next question. So this is polarization. This is important for advanced as well. Okay. Next is particle is released from point A of the track as shown in the figure. It's a smooth track. This height is h. Normal reaction at the highest point is 3 times the weight of the block. This is given. So at the top of the circular track. So when this particle covers reaches this particular point, right, at the top of the track, if the normal reaction from the track is n, this n is given to be equal to 3 mg. Okay. So then we have to find a relation between height and the radius. So firstly we can conserve energy between this point, initial point, and final point. Okay. We can conserve energy. So what is the height dropped? So this height is h. So initial if I say this is the zero potential energy line, the ground as the zero potential energy line, initial potential energy is mgh. Okay. Initial kinetic energy is 0 because it is released over there. At this location, let's say the velocity of the ball is v. Okay. What is the height from the ground? 2 times r, diameter. So final potential energy is mg times 2r, and final kinetic energy we will say it is half mv square. So this is the energy conservation equation. Now we will use this fact. So the particle is over here. So we marked the normal reaction, but there is also the weight of the ball, mg, acting downwards. So the net force at this location is n plus mg. N plus mg is the net force. This will be equal to mass times the net acceleration. At this location, the acceleration will be v square by r, centripetal acceleration, right? N was equal to 3 mg, so this becomes 4 mg. So m cancels out and we get v square as 4 rg. Okay, so now we'll put that over here. 4 rg divided by 2 will make it 2 mgr. So this becomes 4 mgr. So mg cancels out and we get height h as 4r. Okay, first option. Okay, so this is energy conservation, the first step. Initial potential energy, initial kinetic energy equals final potential energy, final kinetic energy. This is that equation. And then this information is given to us. Normal is 3 mg. And then we use a force equals mass times acceleration, F equal to ma, at this location. Net force is n plus mg downwards equals mass times centripetal acceleration. Okay. Next question. This is also April shift. I think the most recent shift maybe. So cylindrical container, its radius is 40 centimeter, volume is 528 decimeter cube. It is placed on a table of same height as that of the container. Okay. So basically I guess this height and the length of the container they are mentioning that is the same. A hole is made 70 centimeter below from the free surface. Find the range of efflux on ground if container is filled completely. So we have to find, so if this is where the particle, I mean this is where fluid is leaving, we need to find this range, the range of this projectile. Okay. So the I think the reason why radius and volume was given is because this was not given, right? This was a memory based problem. So what you will do is you will use this information and find the height, right? So anyways, the main concept is the velocity of efflux from this hole, right, which is the velocity with which the fluid is leaving this hole, is equal to root 2gh, and here h is this height, okay, which is the height of the top surface of the fluid from the hole. This height is given to be 70 centimeters. So using that, you will find the velocity of efflux. Once you get that, this is just projectile motion, simple projectile motion. So we have the horizontal velocity at the top, and we need to find the range. Okay, so if this height is some, let's say, capital H, what is the time of flight of this projectile? The time of flight is root of 2h by g, okay, because there is no vertical velocity, and the range is simply going to be the horizontal velocity multiplied with the time of flight. Okay, that will give you the range. Simple horizontal projectile. Okay, just remember that in the efflux velocity expression, the height h over here is the height from the free surface of the liquid, okay, which is actually 70 centimeters. So here you will put 70, and in this capital H height is the distance of the hole from the ground. So that will be, so this is 105, you have to add this height as well to that, okay. So what is this height? It is 105 minus 70, which is 35. Okay, so here you will put 140 centimeter. That is the only important thing to keep in mind. So you guys can solve it after the lecture. The answer will be 140 root 2 centimeter for the range. Okay. Yeah, I will answer, I will tick mark, and also once you get the PDF, it will be over here on the bottom right, it will be marked. Okay. So next, figure shows an adiabatic container which is divided into two equal parts by an adiabatic freely moving piston. So there is a piston over here, it can move freely to the left or right without friction, and it's an adiabatic container which is divided into two equal parts by an adiabatic freely moving piston. Now this piston, it's also given to be adiabatic. What does that mean? There won't be any heat transfer from the left side to the right side. There cannot be any heat transfer happening between the left partition to the right partition. That's what we mean by adiabatic piston. Both sides contain same gas having gamma equals 1.5. Initial states are also given, P0, V0, T0 for both the gases. If heat is supplied to the left part such that its pressure becomes 27 P0 divided by 8, find volume of right part. Okay, so externally we are giving heat to the left partition. Okay, now once we heat up the left partition gas, what will happen is the pressure will increase. Okay, which means this piston will be pushed to the right. So in the final situation, this piston will move to the right and the right gas will be compressed. So let's just say the final situation is something like this. And the piston is somewhere over here. It moved to the right. It's given that in the final situation, the left gas pressure is 27 P0 divided by 8. So here the pressure is 27 P0 divided by 8. The volume of the left gas changed, right, because the piston moved to the right. Let's say this volume is some VL, and the temperature, well, nothing else is given, so we'll just ignore that. Now what about the right gas chamber? In the right chamber also the pressure will be the same, 27 by 8 P0. Why is the pressure the same? Because if there is a pressure difference between the left and the right, the piston will move, right? If the left pressure is greater than the right pressure, then the piston will move to the right. So in equilibrium, So when the new equilibrium state is reached, pressure on both sides will be the same. Okay. Now what about volume? So total volume is 2V naught, right? Left and right combined. This we assumed it is VL. So here the volume will be total volume minus the volume of the left. Okay. So this is the final pressure, final volume, final pressure, final volume of both chambers. Now we have to find the volume of the right part. So we have to find this volume. Okay. So now we will use the adiabatic equation, right? For the right part, there is no heat transfer happening. So only for the right gas, we can apply PV to the power gamma equals constant. Okay. So which means P1 initial pressure, initial volume raised to the power gamma equals final pressure is 27 by 8 P naught. Final volume is this thing, right? This we will call it as VR, volume of the right chamber raised to the power gamma. Okay, so from here gamma value is 1.5, which is 3 by 2. So we cancel P naught. So VR will be, so what will this be? So we'll have to square it and take the cube root, right? So 8 by 27 raised to the power 2 by 3 and V naught. So what is this? This is 2 by 3 the whole square. 2 by 3 the whole square will be 4 by 9 V naught. So now we have the volume of the right chamber. What is the volume of the left chamber? It will be total volume 2 V naught minus that, which is 4 by 9 V naught. This will give you the volume of the left part, but we just wanted the volume of the right part, which will be third option. Okay. So we can only apply adiabatic gas equation for the right chamber because there is no heat transfer on the right chamber. On the left chamber, we are externally providing the heat, Q. Okay, it is given in the question. We are supplying heat to the left part, so we cannot use adiabatic equation on the left part. So that's why we applied it on the right part, and using that we get the volume of the right. Okay. And in the final case, in equilibrium, both pressures on the left and right will become equal. So that is the answer. Okay. Next is we have position of an ant moving in the YZ plane is given. So S is 2t square j cap plus 5 k cap. The magnitude and direction of the velocity. So if the position is given, velocity is just the derivative, which will be 4t j cap. So velocity is in the j cap direction only. Its magnitude at t equal to 1. At t equal to 1, it is going to be 4 j cap. So 4 meters per second in the y direction. D option. Okay. Next, it's a prism problem. Refractive index of the material of the prism is given. So the refractive index is cot of A by 2. A is the angle of the prism. They are asking what is the angle of minimum deviation. So this is also a formula which we covered multiple times. The refractive index, this can be written as sine of A plus del minimum by 2 upon sine of A by 2. Okay. Now n is cot A by 2. So this we can write it as cos A by 2 divided by sine A by 2. This cancels out. So now you can just compare it, right? Just make that into sine 90 minus theta and compare the angles. Okay, so once you do it, the answer will be A option. Okay, this one. Next is the apparent depth question. So we have two fluids like this, fluid 1, fluid 2. There is a coin at the bottom. So the question is, we are looking at the coin from top, from over here. So the question is, what is the apparent depth? So of course, if we look at it from outside, the coin will appear lifted by some distance, right? What we have to find is this apparent depth, d apparent. Okay. So this has a standard formula, which we also discussed earlier. So the apparent depth is d1 by mu1 plus d2 by mu2. Okay. So 6 divided by 8 by 5 plus 6 divided by 3 by 2. If you do that, you will get the apparent depth of the coin. Okay. That will be the answer. And do this calculation, you will get the answer as 31. Okay, next, in a nuclear fission process, a high mass nuclide is, so mass number is given 236 with binding energy 7.6 mega electron volts per nucleon. It dissociates into middle mass nuclides, and the mass of the dissociated particles are given. It is 118. So if I say this nucleus is some X, okay, and this nucleus is some Y, then the equation will look something like this. X gives 2Y, right? If I have to conserve the mass, because X number of nucleons is 236, Y's number of nucleons is 118, right? So if I want to balance it, I'll have to multiply it with 2. So this is how the equation will look like of the nuclear fission process. Now their binding energy per nucleon is given. Question is, what is the energy released in the process? So now it is easy. The energy released so binding energy per nucleon is given as 7.64x, right? So we will multiply the 7.6 with 236 total number of nucleons, and we will subtract the binding energy per nucleon of Y. So for Y it is given to be 8.6, okay, times number of nucleons is 118, but because there are 2 of these, we will also multiply with 2, okay, and this will give us the energy released in the process. Okay, so this question is also pretty important, the energy released in a nuclear fission process. Also they ask the mass defect problems as well, right? So yeah, moving on. Ball suspended by a thread swings in a vertical plane so that its magnitude of acceleration in the extreme position and lowest position are equal. So the angle theta of the thread deflection in the extreme position will be, okay. So we have a simple pendulum like situation, and we have to talk about the acceleration in the extreme position and the lowest position. Okay, so let's first talk about the extreme position. So this is, let's say, angle theta in the extreme position. So in this case, when it is at the extreme position, the main thing is the velocity here is 0. So which means there won't be a centripetal acceleration component, there will only be a tangential acceleration component. Okay, that is the first thing. And how do we find this tangential acceleration? We'll write the net force. So mg is acting downwards, this angle is theta, So what is this component? It is mg sine theta. So which means the tangential acceleration will be g sine theta. Okay. So in the extreme position, the acceleration is simply g sine theta. Now in the lowest position, the ball will have some velocity, right? And in this case, there won't be any tangential acceleration because there is no force in the x direction, right? So here tangential acceleration will be 0, but there will be a centripetal acceleration of v square by L. Okay, so in the lowest position, there will be centripetal acceleration. In the extreme position, there will be tangential acceleration. Now, how do we find the v square by L? We can conserve energy, right? So this position's height from the top, if this length is L, the height is L cos theta, initial height. Final height is just L, right? So what is the height dropped? The height dropped will be L minus L cos theta, okay? So this is the decrease in potential energy. This will be equal to increase in kinetic energy, half m v square. So from here we can get v square by L, which is what we want. V square by L will be 2g into 1 minus cos theta. So now we have the centripetal acceleration at the bottommost position. Now in the question they mentioned that these two are the same, their magnitudes are same. So we'll equate this to that, right? So what we get is 2 times 1 minus cos theta equals sin theta. Okay, so now I guess you can get the answer. So once you solve it, the answer will be 2 tan inverse of half, which is this question, this one. Okay. IIT, my branch is mechanical. Okay, nickel. 236. What is 236? Okay, next question. Series LCR circuit is given. L, C and R is given. It is connected across a source of 220 volt, 50 hertz. The power factor in the circuit would be. So, okay, so power factor, the way we find it is, power factor is just cos theta, which is R divided by Z. So we need the impedance of the circuit. So for that, it is simple. You just have to find XL and XC. So XL is going to be, inductive reactance is L omega, and the capacitive reactance is 1 by C omega. And the impedance would simply be square root of R square plus XL minus XC, the whole square. Okay, so this is a formula based question. Just keep this in mind. You can do the calculations, everything is given. Inductance, capacitance, resistance is given, and omega, so frequency is 50 hertz, so omega is 2 pi f, which will be 100 pi. Okay, so this is omega. After that, you can just solve it. After solving, the answer will be 1. Okay, this answer will be 1. Next, magnetic field at the center of a wire loop formed by two semicircular wires of radii r1 equals 2 pi meters and radii r2 equals 4 pi meters. The current I is given as 4 amperes. Okay, so the same current flows through this wire. Okay, 4 ampere current flows through the wire. We need to find the magnetic field at the center. So magnetic field due to a semicircular wire, right? So due to the full circle, if we have a circular wire carrying a current I, at the center the magnetic field is mu naught I by 2R. So due to a semicircular wire, it will be half of it, right? Half of this value. So it will be mu naught I divided by 4R. Okay, so smaller the radius, larger the magnetic field. So this wire will have a greater contribution at the point O. So this will be 4R1. Now due to this wire, the magnetic field will be into the page at the point O. You can use right hand rule, right? This is clockwise current. So if you curl your finger in the clockwise sense, thumb will give the direction of magnetic field. So at this location, magnetic field is into the page. Same for this semicircular wire also, the magnetic field is into the page. So these two will get added up. Okay, so once you add them, you will get the total contribution at O. Due to these two straight wires, there won't be any magnetic field at O because they are passing directly through O. Okay. So I hope this question is clear. Now, after getting the answer will be 3. Okay. Next. Rydberg constant is R, longest wavelength of radiation in Paschen series. All right. So longest wavelength of Paschen series. So that will be, so Paschen series are those spectral lines that end up at n equal to 3, right? Lyman, Balmer, Paschen. So the shortest energy transfer will be when an electron jumps from n equal to 4 to n equal to 3. This will have the longest wavelength, right? So wavelength and energy delta E has inverse relation. So delta E is hc by lambda. We have covered this formula right earlier. So the smallest energy difference is from n equal to 4 to n equal to 3. Smallest delta E means the largest wavelength. So longest wavelength will be for this transition. So now you can just use Rydberg's formula. So 1 by lambda equals R times, so this is hydrogen atom itself, so times 1 by 9 minus 1 by 16. Okay, so this would be 7 divided by 9 times 16. Okay, so 9 into 16 will give you the answer. Which IIT? IIT Madras. 8th April shift 2. Next, so yeah, this will be 144, I guess. The value of alpha. Lambda will be 144 divided by 7R. Okay. This question is also pretty popular. Percentage error. So we have to find percentage error in resistance. So R we will write it as V divided by I. So percentage error delta R by R times 100 is delta V by V times 100 plus delta I by I into 100. So this is just a substitution problem. After this, answer will be 3.5. Okay. So here error in V is the uncertainty value, which is 5. V will be 200. Delta I is 2.2. I is 20. And after that you will just substitute. Okay. Next, deflection in moving coil galvanometer falls from 25 divisions to 5 divisions when a shunt of 24 ohm is applied. The resistance of galvanometer coil will be. So they're saying the current drops, right? Deflection, so if we have a galvanometer, the deflection that it shows is proportional to this current that flows through the galvanometer, right? So they're saying that deflection fell from 25 divisions to 5 divisions. So the current became 1/5. So if initial current that went through the galvanometer was Ig, after introducing the shunt resistance, so that will of course be connected in parallel because the current decreases, right? So the current now decreases to Ig by 5. Okay, so in galvanometer, the deflection is proportional to this current flowing through it. They are saying the deflection went from 25 to 5, which means current became 1/5. So initially I am saying some current Ig was flowing. So in this situation, the second situation, when we connect a shunt resistance, the current will become Ig by 5, 1/5. So the remaining current 4 Ig by 5 will flow through the shunt resistance. Okay. That is it. Yeah, these questions will be important. These are just April shift questions mainly, and the previous year questions, JEE Mains. So these are important, yes. So shunt resistance is now given, it is 24 ohm. So now these two are in parallel, so we can say G times I into R basically. So I'm saying galvanometer resistance is G times the current, which is Ig by 5, equals 24 into 4 Ig by 5. So this will give you the answer. 96, I guess, will be the answer. Okay. Next. Biconvex lens of refractive index 1.5 has a focal length of 20 centimeter. Its focal length when immersed in a liquid of refractive index 1.6 will be. So this is also a problem that we did earlier. When we have a biconvex lens and refractive index is given and focal length in air is given, okay. So we will apply lens maker's equation once. So 1 by focal length in air equals n minus 1 into 1 by r1 minus 1 by r2, that will be the 2 by r term for a biconvex lens, okay. That is not important, so we will just keep it as such. This is the equation in air. Now when it is put in water, the second situation, the only difference is the new formula. In the new formula, instead of n here, it will be the relative refractive index. So it will be n divided by nw, right? N divided by the surrounding media's refractive index minus 1. And this term of course remains the same. And now you can solve for this, right? You can just take the ratio of them. Everything else is given. Minus 160 will be the answer once you solve it, okay. Next is a YDSE question. Double slit experiment is given. We have a light of wavelength 400 nanometer. It's given that a dark fringe is observed at P. Okay, so at P we will have a destructive interference. Capital D value is given 0.2 meters. The minimum distance between S1 and S2 is, they're asking the minimum distance, okay, between, so basically this value D is what we have to find. So concept is the same. We have to first find the path difference, right? What is this distance? It is root of d square plus d square. Similarly, this is also square root d square plus d square. This is the distance traveled by the first wave, which is 2 times square root of d square plus d square. And the second wave is traveling in this direction. So the distance covered will be 2 times capital D, right? So minus 2 times capital D. This is the path difference of the two waves. Now the interference at point P is destructive, okay, which means path difference equals n plus half lambda, right? So this will become, now because we need the minimum value for d, this will be set to lambda by 2, okay. Generally it can be lambda by 2, 3 lambda by 2, 5 lambda by 2 and so on, but because we need minimum value of small d, it will be set equal to lambda by 2. So path difference we will set it equal to lambda by 2, everything else is given, right? Capital D is 0.2 meters, lambda value is also given. So now we will solve it, and after solving it you will get the answer as 0.2 mm, okay, 0.2 mm. So this will be 400 by 2, 200 nanometers, and this will be 2 into 0.2, so 0.4. Then you will take it to the other side. So yeah, I guess calculations you guys can do. Cylinder is rolling down an inclined plane of inclination 60 degrees. Its acceleration during rolling down will be x by root 3. Okay, so this is a standard formula, standard result. Oh yeah, and also this cylinder is, just take it as a solid cylinder, okay. So if it is rolling down, the acceleration of the center of mass, right, ACM, this formula is going to be, so if it was not rolling, the acceleration will be g sine theta, that divided by 1 plus I divided by mr square, okay. This is the formula. Now I for the solid cylinder is half mr square, so we will put I equals half mr square here, and the answer will be g sine 60 root 3 by 2 divided by 1 plus half, which is 3 by 2. So 2 cancels out and we get the answer as g by root 3. So the answer for x will be 10, okay. When the displacement of a simple harmonic oscillator is 1/3 of its amplitude, a by 3, the ratio of total energy to the kinetic energy is. So the total energy, right, when you write down the total energy for this simple harmonic oscillator, this formula is pretty important. It is half Ka square, okay. So this is a standard result. Now we need to find the kinetic energy when x is equal to a by 3. So let's say this is x equal to 0. The mass is at x equals a by 3. At this location, we need to find the kinetic energy. So the velocity, so if x is equal to a sine omega t, then the velocity function is a omega cos omega t, right? So it is at x equal to a by 3, so we'll put x equal to a by 3 here. If you put x equal to a by 3 here, you will get sine omega t as 1 by 3, okay. Sine theta equals 1 by 3, so now we can find cos theta. So this will be square root 8. Velocity is a omega cos omega t. A, what is omega root of k by m? Cos omega t from this triangle is root 8 divided by 3. So this is the velocity at this location. Now kinetic energy will be half mv square, half m velocity square. So it will be a square k by m 8 by 9. M cancels out and this is half Ka square times 8 by 9. So now the question is, we need the ratio of, so we need this divided by this. The answer is 9 by 8. T divided by K is going to be 9 by 8. Okay, so the answer for x is 9. Okay. Next is we need to find current in R3, current in this resistor. These two are 4 ohms, this is 2 ohm and that is 1 ohm. Okay. So 4 and 4 in parallel, equivalent is 2 ohm. So the R equivalent is 2 ohm. 2 plus 1 3, 3 plus 2 5. So the total current I is V divided by 5, which is 2 amperes. Okay. Now we need the current in R3 over here. So this 2 ampere gets split because this resistance and this resistance are equal. This 2 splits as 1 and 1. Okay, so the answer will be 1 ampere. Okay, third option. Next is AC circuit, voltage and current are given, V and I are given. We need the average power dissipated in one cycle. So this is the standard formula for average power. The average power, when we calculate it, this turns out to be V naught I naught times the power factor cos theta. Okay. So V naught I naught will be 100 into 100 and cos of the so phase difference is, so 100 this minus this, right? So the phase difference is 60. There will be a 2 here as well, right? It is V I RMS into cos theta, so there will be a 2 here. Now V naught is 100, I is also 100 divided by 2 cos theta. So phase difference is 60, so cos 60 is half. So will be the answer. Okay, so current is in milliamperes, right? So if I have to convert it into SI units, we will have to multiply 10 to the power minus 3. Right? So, no, it was V RMS. The formula was V RMS, I RMS, or we can use V naught I naught by 2 into cos theta. Right? So, cos theta. I'm bad at remembering formulas. So yeah, V naught I naught will be 100 into 100 and I naught is given in milliamperes, so we will multiply it with 10 to the power minus 3 and cos of the phase difference is cos 60, which is half. I guess this should be correct. Okay. There will be a 2 as well, right? There was I naught V naught by 2. Yeah, I guess this, can you guys confirm there was a 2 here, right? In the formula, I naught V naught by 2 into cos theta. I guess this was the formula for average power, just recheck it. Okay. So yeah, 2.5 will be the answer. Yeah, there will be a V naught I naught by 2. Okay, that is the answer. Next is Young's double slit experiment, light from two identical sources superimposing on a screen. The path difference between them is given 7 lambda by 4. What is the ratio of intensity of fringe at this point with respect to the maximum intensity of the fringe? Okay, so this is based on the direct formula. Intensity at any location is 4 I naught. This is the max intensity, cos square phase difference divided by 2. So this is the standard formula. The path difference between the two lights is given. It is 7 lambda by 4, right? Now path difference multiplied with k is actually the phase difference. So k is 2 pi by lambda path difference is 7 lambda divided by 4. This is the phase difference. So this is 7 lambda by 2. Okay. So over here, instead of delta phi, we will put 7 lambda by 2. What they asked is I divided by 4 I naught, right? Ratio of intensity of fringe I with maximum intensity. So I divided by 4 I naught. So the answer is just cos square delta phi by 2, which will be cos square. So this will be how much? 7 pi by 2. So over here it will be 7 pi by 4. Okay. This we will write it as, so if I write it as 8 pi minus pi divided by 4, this is going to be 2 pi minus pi by 4. So this is nothing but cos 45 but squared, right? So this will be half. Okay. Hi Om, welcome back. Now, yeah, that is it. Nothing much. Two sources of light emit power of 200 watts. The ratio of number of photons of visible light emitted by each source having wavelengths 300 nanometer and 500 nanometer is. Okay, so we have two light sources and they emit different photons. So the first light source emits photons of 300 nanometer wavelength, second one emits 500 nanometer wavelength. Both of them have the same power of 200 watts. We have to tell what is the number of photons emitted every second. Okay, so this question also we have done earlier. So let's say the number of photons emitted by this 300 nanometer one is n1 per second. So energy of per photon is hc divided by lambda. This is equal to the total energy released in 1 second, which is 200 joules. Okay, we are talking about energy in 1 second. In the second case, we will say n2 photons are emitted every second. Multiply it with the energy per photon. This will give us the total energy released in 1 second by the second case. Okay, and now the question is, what is the ratio of these two? So basically n1 by n2 will be lambda 1 by lambda 2, so which is 3 by 5. Okay, all right, next. Two particles x and y having equal charges are being accelerated through the same potential difference. Thereafter, they enter normally in a region of uniform magnetic field and describes circular paths of radius r1 and r2. Mass ratio is. So radius in the magnetic field, this formula is mv divided by qb. So the only difference in this question is this velocity we have to find using the first information. They have the same charge and they are accelerated through the same potential difference. Okay, so half mv square equals q delta v, right? So the velocity v square will be 2q delta v divided by m. So we will use the velocity from this equation in this relation, and after that it's just substituting. Okay, all right. So I'll give you the answer. The answer will be last option, which is this option. Charge stored in the 6 microfarad capacitor when points A and B are joined by a connecting wire. So we are basically shorting these 2 points, right? And then the question is, what is the charge in the 6 microfarad capacitor? Okay, so once again, when equilibrium is reached, the capacitors will be fully charged. So in that situation, there won't be any current in this branch or this branch, which means the current will flow through this path basically, right? There won't be any current in, so the current will flow through this branch because there is no current in the capacitors. So what we can do is apply KVL in this branch. I mean, yeah, in this branch. So the potential difference is 9 minus 0. This is grounded. So potential difference is 9. V equals I times total resistance is 6 plus 3, 9. So I will be just 1 ampere. So the current flowing in this branch is 1. So what is the potential difference across this 6 ohm resistor? IR, right? So which is 6 volt. So the capacitor, the potential difference across the capacitor is also 6 volt. And the charge will just be CB, which is 36 microcoulomb. Okay, the answer will be 36. SHM amplitude A and time period 6 pi seconds. Assuming the oscillation starts from its mean position, the time required by it to travel from the amplitude location to x equals root 3 by 2 A will be. Okay, so when we are required to find the time, it's useful to use the circle, right? Phase circle, the phasor method. So in the phasor method, we assume the SHM happening along y axis. Okay, so basically when we say x equal to A, we are talking about this point, right? This is the initial point. And when we say x equals root 3 A by 2, we are talking about a point which is at a distance of root 3 A by 2 along the y direction. Root 3 by 2 A. So the particle will move on the circle, and when it reaches some point over here, when the particle reaches this point, its y coordinate will be root 3 A by 2, which is the SHM's location, right? SHM's location is x. So we need to find the time it takes for the particle to go from here to here. That will give us the answer. So for that, we will find out this angle. So let's say it is theta. We can use trigonometry. So this side length is root 3 A by 2. The area, I mean the radius of the circle is A. This is root 3 A by 2. Cos theta is root 3 by 2. So theta is 30 degrees. Okay. So the particle travels 30 degrees on the circle. So now we just have to find the time it takes to cover 30 degrees. So the angular velocity of this circular motion omega is the same as the omega of the SHM. So this will be 2 pi divided by time period, which is 6 pi. So this is actually 1 by 3. And the time it takes to cover 30 degrees is going to be theta, which is 30 degrees is pi by 6 divided by omega, theta by omega. So 1 by 3. So the time turns out to be pi by 2 seconds. Okay. So x will be 2. Sanjana, it will depend, I'll have to recheck the data for that. I think almost every chapter is important. Some are more important than others, but yeah, I have to recheck it. So, okay, so I guess this question is clear. Particle is moving in a circle of radius 50 centimeter in such a way that at any instant the normal and tangential components of its acceleration are equal. Okay, circular motion is happening, and at any instant they have mentioned the normal acceleration, which is basically, in other words, just the centripetal acceleration, and the tangential acceleration They are saying both of their magnitudes are identical. If its speed at t equal to 0 is 4 meters per second, time taken to complete one revolution will be, okay? We have to find one time period. So let's say its speed is at any instant v. So if the speed is v, the normal acceleration is v square by r, centripetal acceleration, right? This is given to be equal to the tangential acceleration as well in the question. Now the tangential acceleration is basically the rate of change of speed, d by dt of v, rate of change of speed. Now we can just separate it. So dv divided by v square equals dt divided by r. So at time t equal to 0, the velocity will be v naught, which is 4 given to us. And at time t equal to c, the velocity is, let's say, v. So we get, so dv by v square is minus 1 by v. So minus 1 by v will be the integral, and the limits are from v naught to v. And on the right hand side we have t divided by r. So this will be 1 by v naught minus 1 by v. So from here we get the velocity. Now once we have the velocity as a function, we can get omega. So omega will be v divided by r, right? And omega, we will write it as d theta by dt. So this is a slightly lengthy question, and then you have to integrate it once again, okay? So basically find v as a function of time from here, do v by r, that will give us omega. Omega will depend on time, right? And then you have to integrate that relation. That will give us the time. So this is a lengthy one. So the answer after solving will be eight. Okay. Next, series LR circuit connected with an EMF 25 sine 1000 T has a power factor of 1 by root 2. If the source EMF is changed to 20 sine 2000 T, so omega is doubled and the EMF amplitude is also changed, the new power factor will be, so power factor is R by Z, right? In the LR circuit, the Z will be R square plus XL square under root. Now, if the resistance is not changed, then what happens to XL? So initially the power factor was 1 by root 2. So initial power factor is 1 by root 2. So we can say R divided by under root of R square plus XL square is 1 by root 2. Okay, this is the initial situation. Finally, what happens is XL will change because the omega changes, right? XL is L omega. So if you double the omega value, XL will become 2 times. So the new equation will be R divided by under root of R square plus 2XL the whole square, which will make it 4XL square. And this is what you have to find. Okay, so basically what you have to do is find XL from this equation, right, in terms of R, and substitute it here. That will give us the answer. The answer will be 1 by root 5. You guys can resolve it later. Okay. Next, electric field of an electromagnetic wave in free space is represented as E naught cos of omega t minus kz. The corresponding magnetic induction will be, we need to find the magnetic field. So these questions we have done multiple times. So the main idea is this cos omega t minus kz will remain the same. So the other options are just out. This represents the direction in which the wave travels. So if it is omega t minus kz, it will be in the plus z direction. So wave propagates along plus z direction. Okay. Electric field is along the I cap direction. So electric field is along the I cap direction. I mean, you can also see the magnetic field's magnitude is given by E by C. So only this option matches. Okay. So yeah, magnetic field magnitude, if you need, you use the relation E by C. This will give us the peak value of the magnetic field, which is E naught by C. Next is a Zener diode question. Breakdown voltage is 10 volt. So if we have a voltage of greater than 20 volt across the Zener diode, it will break down. Okay. So we need to check if, so ignore the diode for a second. We need to check what is the voltage across. You can think of this like, yeah, so we need to check what is the voltage across this 500 ohm resistance. Okay. So basically ignore the diode for a second. So this is 200 ohm. And this is the diode branch. And we have a 500 ohm like this. Okay, so let's try to find out what is the voltage across this 500 ohm. You know, if we ignore the Zener diode for a second. So if we ignore it, of course, we have 200 and 500 in series, right? So how do we divide the voltage? Voltage is divided proportional to the resistance, right? So the total voltage times, I want the voltage across this 500 ohm. So it will be 500 divided by 500 plus 200, which is 700. So what does this come out to be? 100 divided by 7 volt. This is approximately 14 something volt, right? If you observe, this voltage is greater than the Zener's breakdown voltage, which means we will see Zener breakdown in this question. And if Zener does break down, what happens is the voltage across these 2 points, it will be a constant 10 volt. Okay, so the voltage across the Zener will be 10 volt constantly if the Zener breaks down. So which means the voltage across this 500 ohm will be equal to the Zener's breakdown voltage, which is 10 volt. So if the voltage across 500 is 10 and the total battery EMF is 20, so the voltage across this 200 is also 10. So that's how the circuit looks like. The question is, what is the current through the Zener diode? Okay, that is simple. So in this resistor, current is V by R, so 10 by 200 multiplied with 1000 to get the answer in milliamperes. So this current is 50 milliamperes, and similarly over here the current will be 20 milliamperes. 10 divided by 500 into 1000, 20 milliamperes, right? So 50 incoming, 20 over here, so here the answer is 30. So through the Zener, the current will be 30 milliamperes. Okay. Spherical body of mass 100 grams is dropped from a height 10 meters from the ground. After hitting the ground, the body rebounds to a height of 5 meters. The impulse of force imparted by the ground to the body is given by. Okay, so the impulse is just going to be the change in momentum, delta P. Okay, so before colliding, let's say the velocity of the ball is some u. That u we can find it out because the initial height released is given as 10 meters, right? So u is nothing but root of 2gh1, and after colliding, let's say the velocity is some v. This v also we can find because the final height is given 5 meters. So which means v will be root of 2gh2. Okay, and if you have u and v, the change in momentum is final momentum is mv j cap minus initial momentum is mu minus j cap. Okay, this minus and minus will make it plus, and the answer is m times u plus v in the j cap. This is the change in momentum of the ball. This will be equal to the impulse applied by the ground. Okay, so now that is it. After that, it's just calculation. The answer will be 2.39. Okay, alternating voltage 220 sine 100 pi t is given, and it is applied to a purely resistive load of 50 ohms. The time taken for the current to rise from half the peak value, which is I naught by 2, to the peak value. This is also similar to the SHM question we just did. We use a phase circle, phasor diagram. So the thing is, it's a purely resistive load, which means current and voltage are in phase. So current will also be some I naught sine 100 pi t. We need to find the time it takes for the current to go from half of the peak value to the peak value. Okay, so we'll use the same phasor diagram method. This is the mean position of the SHM. Half the peak value will be somewhere over here, I naught by 2. Peak value will be over here, I naught, right? So I naught by 2, the particle will be somewhere, the particle will be over here. Okay, so basically in the circular motion, the particle goes from here to here, but the SHM amplitude, SHM the SHM value, I mean the peak value changes from I naught by 2 to I, as the particle on the circle goes from here to here, right? So now we use the same method which we used a few problems back. We find out this angle theta. So cos theta is going to be half, which means theta is 60 in this case, right? This is the amplitude, total amplitude, which is I naught, and this distance is I naught by 2. So cos theta is half, or theta is 60. Now we need to find the time it takes for the particle to cover 60 degrees. Omega is 100 pi. So time period is 2 pi by 100 pi. So this is 1 by 50. Okay. Now the time for the particle to go from here to here is just theta pi by 3 divided by omega. This is 50 pi divided by 3. Okay, 50 pi divided by 3, the answer will be 3.3 once you solve it. Next. Block of mass m is placed on a surface having vertical cross section given by y equal to x square by 4. This is a parabola. Coefficient of friction is half. The maximum height above the ground at which block can be placed without slipping is. Okay. Y equal to x square type of a parabola. So the parabola will look something like this. So we have to place some mass in equilibrium at some location. So the forces holding the mass in place is the friction force, right? So we'll have the weight mg acting downwards. Normal reaction will be perpendicular to the tangent at that location. Let's draw a tangent line at that location. Normal reaction will be in this direction. Perpendicular to this tangent line. And then we also have friction force parallel to the tangent. Okay, so this is trying to move downwards, so friction will act in this direction. So this is friction force, this is normal, this is mg. We will also use calculus. So let's just say the tangent angle is theta with the horizontal. Okay, which means normal angle will be theta with the vertical. This angle will also be theta. Tangent makes theta with horizontal, normal makes theta with vertical. So now we'll just do force balance, right? Friction will be equal to mu times n, because we are talking about the limiting case. So this is the horizontal. So we'll resolve mg. So mg is this component along the tangent is going to be, so this angle is theta. This component is mg cos theta. This component will be mg sin theta. Okay. So normal reaction is equal to mg cos theta. And mg sin theta equals mu n. Okay, n is equal to mg cos theta. We'll substitute it here. Mg cancels out and we get tan theta equals mu. Okay. Tan theta you can get by differentiating it. Dy by dx. Dy by dx is 2x divided by 4, which is x by 2. Dy by dx is also tan theta, which is equal to mu. Mu value is half. So x is equal to 1. And the question is, what is the maximum height? So we need the y coordinate. X coordinate is equal to 1. So if I put 1 here, the y coordinate becomes 1 by 4 meters. Okay. Next, we have a graph between maximum kinetic energy of the photoelectrons against the frequency. So Ke max, K max equals HF minus work function. Maximum kinetic energy against the frequency of the incident photons. The slope of the graph gives. So slope of this function is actually this value, right? Y equal to mx plus c. So here x is basically f, frequency, right? So the slope is going to be this thing, which is the Planck's constant. Okay, A option. Beam of unpolarized light, intensity I0 passes through the Polaroid A. So unpolarized light, once it passes through A, so before passing through A, it was I0. So after passing through A, it will be I0 by 2. We saw it in the second question. And then it passes through B, which is at an angle of 45 to A. So then it passes through B, and after passing through B, it will be I0 by 2 cos square this angle 45, and cos square 45 is half, so this is I0 by 4. So basically they are asking that I0 by 4. Okay, so unpolarized light, once it passes through a Polaroid, its intensity becomes half, and then it passes through another polarizer which is oriented at an angle theta. So the new intensity becomes this intensity I0 by 2 times cos square theta. Okay, that will give us the answer. Next, particle of charge minus q and mass m moves in a circle of radius r around an infinitely long charge of linear charge density lambda. Time period will be given as, okay. So long line charge, if the charge density is plus lambda, we know the electric field at a distance r, perpendicular distance r, this is radially outwards and its magnitude is 2k lambda divided by r for a long line charge. Okay, so we have a minus q charge which moves along a circular path, something like this. So from the top view it will look like a circular motion. Okay, so we'll just draw the top view itself. So from the top view, the line charge is going into the page basically. This radius, we'll say it is some r. This is the minus q charge moving with some velocity. The electric field is outside 2k lambda by r, but because this is a minus q charge, the force on this minus q will be towards the center. The force will be towards the center. The magnitude is 2k lambda by r electric field multiplied with the charge. Okay. Now net force towards the center is equal to mass times centripetal acceleration, circular motion idea. So 2k lambda divided by r into q, F net equals mass times acceleration, v square by r. So from this we get v, so v square will become lambda q divided by 2 pi epsilon naught, writing k as 1 by 4 pi epsilon naught. There will be an m, r cancels off. Okay, seems correct. I guess this is it. So this is going to be v. Okay. Now they want the time period of the circular motion, that is 2 pi r by v. So time will be 2 pi r divided by this v, and v you can just substitute. So oh yeah, we didn't have to substitute k, but yeah, the answer will be D option once you solve it. Main idea is you need to know this formula, electric field, and then we will write the net inward force equals mass times v square by r, centripetal acceleration. Next, escape velocity of a body from Earth is 11.2 kilometers per second. If the radius of a planet is 1/3 of the radius of Earth, so then radius of the planet is r by 3 and mass of the planet is 1/6 of that of Earth. The escape velocity in this planet is, so escape velocity formula is also very important, root 2 g m by r. Here m is the mass of the planet and r is the radius of the planet. Okay, so now we just need to take ratio. So velocity of planet, velocity of escape velocity from the planet divided by escape velocity through Earth is going to be equal to root of mp divided by mr multiplied by mp divided by me, mass of Earth, times re divided by rp. Okay, so you have the rp and mp values, you can just substitute over there, and I guess the answer becomes 1 by root 2 times. Okay, the answer will be 7.9 once you solve it. Okay, next, relation between time and x is given. Time is alpha x square plus beta x. Alpha and beta are constants. The relation between acceleration and velocity is, so dx by dt will give us velocity. So we should think of differentiating it. So differentiate both sides with respect to time. So on the left hand side we'll have 1. Over here we are differentiating with respect to time. So we need to use chain rule here. So first we'll differentiate x, which will make it 2 alpha x, right? X square's derivative is 2x. Now we'll differentiate x with respect to time, which is dx by dt. So applying chain rule here. And over here it is beta times dx by dt. Beta is a constant. Okay, so dx by dt is the velocity. So we get velocity v as, we'll take v common. So 1 divided by 2 alpha x plus beta. Okay, so we took v common and sent everything to the other side. So velocity is 1 by 2 alpha x plus beta. Okay. Now for acceleration, we'll differentiate velocity once. So dv by dt. This will give us acceleration. So first we'll differentiate this entire thing. So this is kind of like a 1 by x. Derivative of 1 by x is minus 1 by. Derivative of 1 by this thing is minus 1 by that thing squared. So minus 1 by 2 alpha x plus beta the whole square. And now we'll differentiate whatever is inside. So 2 alpha is a constant. X derivative is v, right? If you differentiate x with respect to time, it will be v. So I guess this is correct. So now we'll just solve for a. Minus 2 alpha v divided by, okay, so now this thing 1 by 2 alpha x plus beta, 1 by 2 alpha x plus beta, this is v. So 1 by 2 alpha x plus beta whole square will become v square. And this answer is minus 2 alpha v cube. Okay, third option. Okay. Next question. When a metal surface is illuminated by light of wavelength lambda, the stopping potential is 8 volt. Okay, so the first equation is E times the stopping potential equals hc divided by lambda, energy of photon, minus the work function of the metal. Now the second equation is the same surface is illuminated by light of wavelength 3 lambda, potential becomes 2 volt, stopping potential. So E times the stopping potential equals hc divided by 3 lambda, in the second case, minus phi. Same material, so work function is the same. We need the threshold wavelength. Okay, so threshold wavelength, let's call it lambda naught. hc by lambda naught is phi, work function. Basically we need to write the work function as hc by lambda naught. So what we'll do is we'll multiply this with 4 and subtract these two, right? So E into 8, firstly let's see if the substitutions are correct. Yes. So 4 into 2E, and instead of 2E we'll substitute this. So 4 times hc by 3 lambda minus phi equals hc by lambda minus phi. So minus 4 phi, if I take it to the other side, it will be 4 phi minus phi, which is 3 phi. And on the left hand side, we have 4 hc divided by 3 lambda minus hc by lambda. So 4 by 3 minus 1 hc divided by lambda. So phi becomes hc divided by 3 lambda into 3, 9 lambda. So if I write phi as hc by lambda naught now, the answer will be 9 lambda. Okay. Next. Logic gate is given, we need to find the output. What is the output? Okay, this is A, this is B. It passes through a NOR gate, so NOT gate. So here it will be A bar or A complement. Here the input will be A complement, and here the input will be B complement, and then it passes through a NAND gate. So firstly it will be processed as A complement dot B complement, but because that is a NAND gate, this whole thing will become a complement. This we can simplify using De Morgan's law. Okay, like if A dot B the whole, so we will use A plus B the whole bar equals A bar dot B bar. Okay, so this thing will become A plus B. Okay, this dot will become a plus, and these two will be complemented. So A complement will become A, B complement will become B. A plus B is OR gate, right? So the output over there will be similar to, so this entire thing is similar to an OR gate. Yes, Arpita, yes, that's my channel, yes. Okay. Next, particle performs SHM with amplitude A. Its speed is increased to 3 times at an instant when its displacement is, this is going to be 2A by 3. The new amplitude of motion is NA by 3, so we need to find the value of N. So when the particle who's performing an SHM, it is at a distance of 2A by 3 from the mean position. Its speed, we are increasing it by 3 times, okay, at that location. Then what happens to the new amplitude? That is the question, okay. Now let's begin. So this is, let's say, the mean position line. So the particle is at a distance of 2A by 3 from the mean position, okay, and at this location, let's just say the velocity is V. This V we'll have to find, but in the question what we are doing is, instead of this V, we are making the velocity 3V externally, okay, and because of increasing the kinetic energy, what will happen is, now the amplitude will change, as we will see. We need to find the new amplitude because of this increase in kinetic energy, okay. So the first important thing to keep in mind here is the total energy of the SHM formula. This we saw while earlier. This was half K A square, right? So if I find the total energy, I can relate it to the amplitude basically. So my goal should be to find the total energy at this location, okay. So let's see. So let's just take the SHM equation as x equals A sine omega t, okay. So the velocity will be A omega cos omega t, first of all. Now x value is 2A by 3, so we will put 2A by 3 here, and we'll get sine omega t. Actually, we can also use the formula, the direct formula, to find the velocity. So you must be knowing this formula, which is omega under root of A square minus x square, right? Velocity at x distance from mean position. This formula we can use. So omega will be square root of k by m times A square minus, the distance is from the mean position is 2A by 3. 2A by 3 square is 4A square by 9. This thing under root. So if I just write it as omega for now, this becomes root 5 A omega by 3, okay. So using this formula, we can get V directly. So now we know V. This velocity was made 3 times at this location. At this location, the new velocity is made 3 times this velocity. So new velocity will be this times 3, which is root 5 A omega. This is the new velocity. Okay. Now we will find the total energy at this equation, I mean at that location. So that will be half k x square. X is 2a by 3. So 4a square by 9. This is the half k x square term, potential energy term, plus kinetic energy term, which is half mass velocity square. So that will be 5 a square omega square. Omega square is k by m. M cancels out. This is 5 ka square by 2 plus 4 by 9. So if I take half ka square common, inside we will have 4 by 9 plus 5. This becomes 49 by 9. So the new total energy is half k. 49 by 9 a square, which I can also write it as 7a by 3 the whole square. Okay. So this is the new total energy. Initially the total energy was half k a square. Now it has become half k 7a by 3 the whole square. Okay, so the logic behind finding the total energy was the total energy of SHM, it is half k amplitude square. So if I find the new total energy, this is nothing but half k new amplitude square. Okay. So new amplitude from here is 7a by 3. So n will be 7. Okay. Yes, Om, it will be 7. Yes. Next is mass number of nucleus having radius equal to half of the radius of nucleus with mass number. So this is based on a result. The radius of a nucleus having mass number A can be written as R naught, a constant, times a to the power 1 by 3, right? So now we just have to take the ratio. So R2 by R1. We want R2 by R1 to be, so R2 by R1 is half, okay, and this will be equal to A2 by 192 raised to the power 1 by 3. So I guess the answer will be 192 divided by 8, which is 24. Okay, 24 is the answer. Next, block of mass 5 kg is placed on a rough inclined surface. If F1 is the force required to just move the block up. Okay, so in the first case we are applying a force F1, and this force is the minimum force that we have to apply to move the block up. Okay, so the friction force is going to be, so we need to overcome this friction force, right? And there will also be an mg sin theta downwards. Mass is 5 kg. F1 will be, we have to overcome the mg sin theta, which will be 5 into 10, 50 into sin 30, 25. And then we also have to overcome this friction force, which is mu times friction will be mu mg cos theta. So mu is 0.1, mg is 50, cos 30 is root 3 by 2, right? So this is 5 root 3 by 2. Okay, so this will be F1, 5 root 3 by 2. Yeah, it is correct. Yeah. So just to push it upwards, if you are pushing the block upwards, friction will be downwards, and mg cos theta is always downwards. So mg cos theta plus mu mg sin theta plus mu mg cos theta will be the F1 force. Now in the second case, F2 is the force required to just prevent the block from sliding down. Okay, so in this case the only difference is if we leave the block as such, the block's downward force is mg sin theta, so friction will act upwards. So the only difference is that in the second case, friction will be in the opposite direction. So F2 will be 25 minus 5 root 3 by 2. Okay, so if we leave the block, it will accelerate downwards because mg sine theta is bigger than the friction force, right? So what will happen is friction will act in the upward direction for the second case. So we'll have to apply a force of this much to prevent the block from sliding down. Okay, so now the question is, what is the difference between these two? And that will be 5 root 3. Okay, A option. All right, next. Unpolarized light is incident at an angle of 60 degree on a transparent medium from air. The reflected ray is completely polarized. Okay, so this is the Brewster's angle example. So we have an incident light ray like this, and it refracts, and in the Brewster's angle case, the main idea is the reflected light and the refracted light will be at a 90 degree angle to each other, and this will be equal to the Brewster's angle. And this incidence angle is also given. This angle is given to be 60 degree. So angle of reflection is also 60. Okay. Now the question is, what is the angle of refraction? The angle of refraction will be this angle, theta. So this total angle is 180, 90 plus 60, so this will be 30 degree. Okay. So C option. So this is the Brewster's angle idea. So which is like when we have an unpolarized light, and if this is incident at Brewster's angle, what happens is the refracted light, the reflected light is completely polarized. Okay, and that happens when the incidence angle is equal to the Brewster's angle. And in the Brewster's angle, if you read NCERT, you will see the reflected light and the refracted light have a 90 degree angle between them. Okay, so using that information, this we can find it out because angle of incidence is equal to angle of reflection. So this angle is 60, this angle we know is 90, total angle is 180, so that refraction angle will be 30 degrees. Okay, next. Distance between plus q and minus q is 2L, minus 2q and 2q is 4L. We need to find the potential at point P. So this, of course, this distance r is much greater than L. This is to be considered as a point dipole. Okay, so we have two dipoles at the point O. It is this minus q plus q system and this minus 2q plus 2q system. So we will consider them as two different dipoles. So this minus q and plus q, there is a dipole, it contributes a dipole moment in the x direction, and let's call it P1. And so dipole moment is the charge multiplied by the distance between the charges, and the potential due to this dipole at a location R making an angle 60 degree. This formula is given to us by Kp cos 60 divided by R square, Kp1. Okay, now the only difference is the next dipole will be towards the minus x direction. Dipole moment direction is along from the minus to plus. Okay, so now the second dipole, when you consider P2, this will be the second charge, which is 2q. multiplied by the distance between the charges, okay, and that is 4L. This will be the second dipole moment. But here you need to keep something in mind. The dipole moment direction is to the left and the point is still over here, making an angle 60 degree. So here you will use the formula Kp, same formula Kp cos theta by r square, but the theta you will choose is this angle, which is 120. Okay, so the potential due to this P2 will be Kp2 cos 120 divided by r square. Okay, so basically this would be negative and this would be positive. Their sum will give us the total potential at the point P. Okay, so once you add it, the answer will be 27. This answer will be 27. All right, that's it. Next, de Broglie wavelength of proton and alpha particle are lambda and 2 lambda respectively, the ratio of their velocities. Okay, so lambda is h divided by mv. So lambda of proton divided by lambda of alpha particle is so proton mass I am considering it as m p and velocity I am saying vp. For alpha particle, the mass of the alpha particle is the helium nucleus, right? So it has 2 protons and 2 neutrons, so its mass we will approximately write it as 4 times mass of proton times velocity of the alpha particle. And now you can just substitute. This is going to be half. So Vp divided by V alpha will become 8:1, I guess. Which formula, J? Which formula are you saying? This Kp cos theta one? I mean, that is just that is to be remembered only. So if the dipole moment is in this direction and r is in this direction, in the formula Kp cos theta by r square for potential, this is the angle we choose. Okay, and this angle is the angle of the dipole with this r vector. It's the angle between the dipole moment vector and the r vector. That is the angle theta we need to choose. Okay, so here the dipole moment vector is along minus x, r is in this direction, so this is the angle that we need to choose. Okay, next, time period of SHM of this mass. So this is a spring mass system. This we can easily simplify, right? So this is equivalent 2 springs in parallel, so equivalent becomes 2k. 2k in series with k will make it 2k by 3. So this whole thing is 2k by 3 and it is in parallel with k. So 2k by 3 plus k, that would be 5k by 3. So this is like a equivalent spring of 5k by 3 attached to a mass m. So the time period will be 2 pi square root of m divided by 5k by 3. Okay, so I don't know if the 2 missing over there is a printing error, or I guess the 2 is not there. Yeah, so the 2 will be basically taken inside the square root. So this particular factor is 3 into 4, so alpha will be 12. Okay, yes Om, it will be 12. Next, the experiment to measure focal length of convex lens, least counts for measuring u and v are delta u and delta v. So these are the errors in the measurement of u and v. The question is, what is the error in measurement of focal length? Okay. So firstly, we will write down the lens formula. 1 by v minus 1 by u equals 1 by f. Okay. Now what we'll do is we'll differentiate this because we want the percentage error in focal length. So we want a term like dv by v. Okay. So we will differentiate on both sides. So the RHS becomes minus 1 by f square df, and this becomes minus 1 by v square dv, and the other one will become plus 1 by u square du. Okay. Now the percentage error, so this should be the percentage relative error. The percentage error, okay. So basically the percentage error will be something like delta f by f. Actually it's not percentage, it's just the relative error, delta f by f. So what we need, so of course we'll write everything with plus sign because we want the maximum error. So the relative error is df by f. This is what we want. You can change the symbol for d to delta as well, right? So we have df by f square here. So what we'll do is we'll take one f and send it to the other side. So this becomes f multiplied with dv by v square plus du by u square. Okay, that will be the error. I guess this 2 is wrong. So probably some printing error. Let's see. Okay, so the question is they just asked the error. So the error in f is just delta f. Okay. So what we had to find was a delta f. So basically we'll multiply f square to the other side, right? So this will become f square because we just wanted the error in f, not the relative error. So the answer will be third option. Okay. Next. Width of one of the two slits in Young's double slit experiment is 4 times that of the other slit. So this is the thin rectangular slit. Okay. So one slit's width is 4 times the other. So which means 4 times more energy comes in from the wider slit, which means the intensity coming from the, if I say the intensity through this slit is I1 and through this slit is I2. So I1 will be 4x basically, 4 times the intensity from the other slit because the width is 4 times more, the 4 times the energy comes in basically. Now the question is, what is the max to min intensity ratio? So this formula is a pretty common one, I max divided by I min for interference, right? This is going to be root of I1 plus root of I2 divided by root of I1 minus root of I2 the whole square. Okay. So I2 by I1 or I1 by I2 is 4. Okay. So this thing you can use componendo dividendo. So I take the roots, so this becomes 2. Now if I add, so root I1 plus root I2 divided by root I1 minus root I2 will make it 3 by 1, and we have to square it, I guess. 9:1. Okay. Or I mean, if you don't understand this, you can just put root I1 as 2 root I2 into this equation. Okay. Next, in the diagram given below, there are 3 lenses. Okay, so this is a flat surface and here we have a convex type surface. Okay, and okay, and this is filled with water, and water's refractive index is given. Okay, this R value is equal to R1 in terms of magnitude, and over here we have glass. This is glass. This radii of curvature is R2. Glass refractive index is given, and below that we once again have water. So we need to find the equivalent focal length or equivalent power. Okay. So there is a direct formula for this. Okay. 1 by F, or basically equivalent power. So we start from the first surface. So here the refractive index is 1 and water's refractive index is 4 by 3. So refractive index of this minus refractive index of, so mu R minus mu L, so that will be 4 by 3 minus 1 divided by the radii of curvature of the surface, which is infinity. So this is the first surface. Now the next surface where refractive index changes is this one, right? And to the left the refractive index is 4 by 3, to the right the refractive index is 3 by 2. Mu in the right minus mu in the left divided by radius of curvature. Now here the radius of curvature is to the left side, right, in the up direction. So the magnitude is given as R1, so this will be written as minus R1. Now this is the, so first surface we wrote, second surface also we wrote. Now we move on to the third surface, and at this surface on the left side it is 3 by 2, on the right side it is 4 by 3. So we will write 4 by 3 minus 3 by 2 divided by, here also the radius of curvature is in the left direction, so we will put a negative sign, minus R2. Okay, and this will give us the equivalent focal length. So 1 by F will be 9 minus 8 divided by 6, minus 1 by 6 R1, and that is 8 minus 9 plus 1 by 6 R2. So if I take minus 1 by 6 common, it will be 1 by R1 minus 1 by R2, so first option. Okay. All these questions see me see. Yeah. Mains problems are easy only, right? It's a matter of speed, I guess. Physics questions are coming easy itself. Next, light described by this equation, electric field equation is given. It falls on metal surface of work function 2.8 electron volts. Maximum kinetic energy of ejected photoelectrons is. Okay, so max kinetic energy will depend on the frequency, right? The frequency of the incident photon. Ke max is equal to hf minus work function. So this particular electric field function, if you recognize it, it is the superposition of two waves, right? This is some E1 sine omega 1t plus E2 sine omega 2t, right? This is the superposition of two waves, and so if I look at it like two separate light waves, this first wave's frequency is 3 times 10 to the power 15. The second electric field's frequency is 12 into 10 to the power 15. So this part, this light has greater frequency, right? So this is omega 1, let's say this is omega 2. Omega 2 is 12 into 10 to the power 15, and omega 1 is 3 into 10 to the power 15. Using this, you can find the frequency. So clearly the second light wave, this one has greater frequency, which means it will have, which means the photons coming from this wave will have greater energy, right? So that wave will eject kinetic energy. That, I mean, these photons will eject photoelectrons with the maximum kinetic energy. Okay, so all you have to do is convert this omega 2 into frequency. So omega 2, convert it into frequency. So frequency is just omega divided by 2 pi. So find out what F2 is, and then the max kinetic energy will be simply HF minus the work function. That is it. Okay, so after calculations, the answer will be D option, 5.1. Okay, next. This graph is the graph between potential energy and the distance. Okay, U versus X is the graph provided, and we need to say compare the magnitudes of force acting on the particle from high to low. Magnitude of the force. So firstly, the magnitude of the force. So if this is U, the magnitude of force is given by minus du by dx, right? The force is given to us by minus du by dx, which is basically the slope of the U versus X graph. So if I have to compare the magnitude, of course the minimum magnitude will be in this region CD. In this region the force will be 0. Why is the force 0? Because the slope is 0, right? So that will of course be the smallest magnitude, which means only one option matches. So the answer is the first option. The rest of the paths you can just compare the slope. The greatest slope regions will have the greatest force, right? So BC, as you can see, is the line with the greatest slope. That will be having the largest force. Okay, but we only needed to see the force in the region CD. Next, two identical thin rods of mass capital M and length L are given. We need to find moment of inertia of the combined rod system about an axis passing through point P and perpendicular to the plane of the rods. So yeah, so basically we need to find moment of inertia about this axis. So due to this first rod, it is simple, it is ml square by 3. Now due to this rod, we need to use parallel axis theorem. So first we'll write it about the center of mass of the rod, which is ml square by 12. And to this we'll add m times d square, which is L square. Add these three, that will be the answer. So 4 by 3 plus 1 by 12. This, the answer should be 5 by 12 ml square. The answer for x will be 5. Okay. Unless we made some mistake. Is it 17? Whoa, where is the mistake? ml square by 12 plus m into L square plus ml square by 3 seems correct. 4, 5 plus 12, yeah, it will be 17. 17 by 12 ml square. 17 is the answer. Okay. Next. Collimated beam of light diameter 2 mm is propagating along x-axis. Beam is required to be expanded in a collimated beam of 14 mm using a system of two convex lenses. If first lens has focal length 40, then the focal length of the second lens is. Okay, so basically we have parallel light coming up. Light is parallel to the, so this diameter is given. This beam diameter is given, it is 2 mm. Okay, and we need to make this beam diameter into 14 mm. And we are using two convex lenses. The first lens has focal length of 40. Okay, this convex lens has focal length of 40 mm. So basically, if parallel light rays get processed by the focal this particular convex lens, it will finally end up in the focus, right? So if I just take this one light ray, so after being processed by the lens, it will pass through the focus. Similarly, even this light ray, after being processed by the lens, will hit the focus. Okay. Now the thing is, we have one more lens whose focal length is something we have to find. So that lens will be kept somewhere over here. Let's say that lens is kept over here. This lens will have some focal length f. This is what we have to find. The final ray should also be parallel lights itself. So after this green light hits the blue convex lens, the light rays should once again be parallel to the axis. Okay. So this is of course not the actual ray. So this is the the diagram of the situation. Firstly, we have parallel rays coming. They get processed by the first lens, and after being processed, parallel rays converge at the focus, right? So basically this distance is 40 mm. Now the thing is, these rays continue, they pass through the second lens and they once again become parallel. This is the ray diagram of the situation, right? Now the final diameter, we want it to be 14 mm, right? So then the question is, what is now of course this distance is also f, the distance of this location to the optical center. This is also f, because we want this ray to be parallel to the optical axis, and that happens when the incident light is from the focus. Okay, so this point is also the focus of this lens. So once we know that, it is simple. We just need two similar triangles, right? So this is triangle 1, base is 2 mm, height is 40 mm. This is triangle 2, base is 14 mm, height is f, right? So these are two similar triangles. So 2 mm divided by 40 mm equals 14 mm divided by f. So the answer will be 280 mm. Yeah, 280. Basically the thing is, this point is the focus of the first lens and the second lens. That is the only thing you had to observe. Next is, we have two identical metallic spheres of radius r, each having a charge q and mass m. Their centers have an initial separation of 4r, but the spheres are given an initial speed of u towards each other. Minimum value of u so that they can just touch each other. So here we need to include the electrostatic attraction and the gravitational attraction. They both have the charge q, so they will repel electrostatically. So in the initial situation, the spheres were at a separation of 4r. Okay, so two spheres, radius is r. So this distance was 4r initially, and they were given a speed of u towards each other. Now the thing is, we want them to just touch each other. So in the final situation, our system will look something like this. And when the system reaches this situation, in this case the separation is 2r, we want the speeds to be 0, right? This means the spheres just touch each other. So this is initial situation, this is final situation. Now all you have to do is initial kinetic energy, initial gravitational potential energy, initial electrostatic potential energy, equate it to the final. Okay, that will give you the answer. And yeah, option 4 will be option 4. Okay, next, a cylindrical tube AB of length L closed at both ends contains ideal gas of 1 mole having molecular weight m. Tube is rotated in a horizontal plane with constant angular velocity omega. If PA and PB are pressures at A and B, then we need to find. So we need pressure as a function of this radius, radial distance. Not radial distance, we want the pressure at PB basically in terms of PA. Okay, so we will solve it in the rotating frame. Okay, so in the rotating frame, the rod will appear to be at rest. So if I go a distance of, let's say, x, and if I take an element, a tiny element whose width is dx. So firstly, the pressure of the gas varies as we move along the tube, and the reason is because of the rod's rotation. That you can think of this in terms of the centrifugal force. So if we are solving it in the rotating frame, a tiny volume like this dx will experience a radially outward centrifugal force, right? And this extra force that the elements feel towards the right makes the pressure at different locations different. So we will calculate that. So we will say the pressure at x is P. Okay, so the pressure at this location x is P, and at the location x plus dx we will say the pressure is P plus dP. Okay, now the thing is, if you look at this tiny volume of the gas, this length is dx, the area of cross section of the tube is it given? Okay, so we'll ignore it for now. There will be some area of cross section, right? Let's call it A. So the volume of the gas is dx into A. So from the left, this system will feel a pressure of P into A, and from the right, the pressure will be, the force will be P plus dP into area. Okay, so now what is the net force? And the volume dV is going to be dx into A. Okay, so this is the element of the gas that I am looking at. So now we need the change in pressure dP. So this thing, so as we are working in the rotating frame, there will be another force, which is the centrifugal force, and the centrifugal force will be radially outward, so in this direction. And centrifugal force magnitude is dm omega square x. Dm, I can write it as density of the gas into dV omega square into x. Okay, this is the centrifugal force. Now these three forces are balanced. So if you observe, this PA cancels out with this PA, so the only leftward force is dP into A. This will be equal to rho dV omega square x. So rho omega square x, dV I can write it as dx into A. So area cancels off, and I will get dP as rho omega square x dx. Okay, so now it's an integral, simple integral. So at x equal to 0, that is basically the location A. So, oh yeah, and also the density is also variable, right? We can write the density of an ideal gas using the relation Pm equals rho RT. So the density of the ideal gas, we can write it as m by RT, these are constants, into P. So density of the ideal gas depends on the pressure as well, so we have to include that too. So dP equals Pm by RT. So this will be Pm by RT times omega square x dx. Okay, so now you take P to this side and it will be a log integral on the left side. Okay, so dP by P, if you integrate that, that will be log P ln P. And on the right hand side we have m omega square upon RT. X dx will be x square by 2. So now we'll put the limits. So at x equal to 0, the point is x equal to A, right? Over there, the pressure is PA, and at x equal to L, the point is PB, so the pressure over there is PB. So from here, ln PB divided by PA is equal to m omega square by RT times x square by 2, that will be L square by 2. Okay, so PB equals PA times e to the power this thing. So I get, just check the options. I guess it will be option 3. Yeah. Okay, so the main idea was there is a centrifugal force outwards. At x plus dx, we choose P plus dP, pressure. At x, we choose P, and then we do integration. Next, in this case, we have xp. xpqy is a vertical smooth long loop having a total resistance R, where px is parallel to qy. Okay, so these two are parallel, and separation between them is L. A constant magnetic field B perpendicular to the plane of the loop exists here. Rod CD of length capital L and mass m is made to slide down from rest under the gravity. The terminal speed. So terminal speed, whenever is mentioned, that just means the net force on the rod is 0. So we have a conducting rod that slides on this metallic rails, and eventually it attains terminal speed. Okay, so let's say that terminal speed is V. So this is a formula based problem. So basically the downward force, in the downward direction we have force of gravity acting, right, mg, and this will be of course opposed by the ILB force, right? And you guys can do the calculation. The current will be EMF divided by resistance. EMF will be given by the VBL formula. You guys can do it later. Basically ILB will be equal to mg in the terminal speed case, net force 0. I guess about 30 more questions, maybe 20 to 30. So next is laser beam of intensity So this is just to revise the intensity formula. If you have a electromagnetic wave and the electric field or magnetic field intensity, I mean the magnitude is given, then the intensity formula is half epsilon naught E square into C. C is speed of light. So here actually the magnitude of magnetic field is given. The amplitude of, okay, magnetic field is asked. So we will use the relation E equals B naught into C. So now we'll just substitute that here, and then it's a formula substitution problem. So the answer after solving will be the first option. You can check it out. Next, 3 identical bubbles. Okay, so this is a bubble merging problem. We have done this like I guess 10 times. So here I am just discussing the main concept. It is volume conservation, right? So these 3 merge together. So initial volume equals final volume, and after that what you can do is, so we need the ratio of potentials on initial bubble and that on the final bubble. So initial bubble, let's say, has charge q, radius r. So initial potential will be kq by r. Now when these 3 merge together, the final sphere, let's say you find out the radius as capital R, charge will be 3q. So the new potential will be k3q divided by r, capital R. Okay, and you need to find the ratio. Okay, so the answer I will just mention here. The answer will be the first option once you calculate it. Next, this is a statement based problem. For a mechanical system of n many particles, the total kinetic energy is the sum of kinetic energies of all the particles. Yes. So if we have like n particles, then the total kinetic energy is sigma half mi vi square. Right, you basically add their individual kinetic energies and sum them up. That will give you the total kinetic energy. This is true. The second statement, they are saying the total kinetic energy can be the sum of kinetic energy of the center of mass and the kinetic energy of all particles with respect to center of mass as the reference. This is also true. We proved this theorem, right? So K can be written as KCM plus kinetic energy of all particles with respect to center of mass, right? Now this KCM becomes half total mass velocity of center of mass square, and this is the kinetic energy of all particles with respect to the center of mass. So that is also true. That's a theorem we prove in center of mass, and yeah, so basically both statements are correct. Next is this question. Here the switch is just turned on, I guess. Okay, so this switch over here, this is just turned on. Then the question is, what is the initial current through this ammeter? So the main idea here is simple. So right after we switch on, connect this switch, right before turning the switch on, the current through these 2 inductors were 0, right? So the thing is, right after you switch you turn it on, what happens is, for time t equal to 0 plus, which is basically right after you turn it on, the currents through the inductors remain the same as the currents before, which means the current through this branch is 0 and the current through this branch is also 0. So the only branch that is left is this one, and over here we just have to apply Ohm's law. So 9 ohm resistance, 9 volt battery, so the current is 1 ampere, and that is it. Okay, and this is only true right after we turn on the switch. Okay, so the answer will be 1 ampere. Yes, option 3. Next, 2 balls with masses m and 2m are attached to both ends of a rigid rod, length d. If angular momentum of the system is L about an axis passing through the center of mass. So we have a rod like this, and we have a point mass m and 2m attached at the ends of these rods. So center of mass will be over here at a distance L by 3, and from the other end it will be 2L by 3. So this is also the axis, okay, of rotation. Then the question is, they have given the angular momentum, we need to find the angular velocity. So for fixed axis rotation, the angular momentum is simply I omega. So all you have to do is find the moment of inertia about this axis, which is 2m L by 3 square plus m into 2L by 3 whole square into omega. Okay, and this will give you the answer. It will be option 2. Okay. Next, light traveling from medium A to medium B separated by a plane interface. If light undergoes TIR during its travel from medium A to medium B, speed of the waves are also given. So using the speed ratio, you can get the refractive index ratio, right? Using the speed ratio, and once you get this refractive index ratio, like sine theta c is just n2 by n1, right? N rarer upon n denser. So the answer, you can confirm it, it will be option D. Okay. So I'm ignoring the formula based questions. Now this question, okay, so I guess there is a mistake in the diagram. In the question, the disk is like this and the axis of rotation is perpendicular to the plane of the disk. Okay, so this is how the diagram is. Okay, so basically in this diagram we have a disk whose mass is capital M, and two tiny disks are removed from the bigger disk. Okay, then we need to talk about the moment of inertia about this axis. That is a question. So here the first we will consider this whole disk whose mass was capital M. This moment of inertia about this axis is mr square by 2. So now we will subtract the moment of inertia contribution due to these two small disks. Okay, actually they are both symmetrically placed, so we just have to calculate it for 1 and multiply it with 2. Okay, so this disk, what is the mass? So the total disk has a mass of capital M. So pi r square has mass of capital M. So the area of this small disk is pi r by 4 the whole square. Okay, so this is pi r square by 16. So which means the mass of this disk will be m by 16. Okay, so now the moment of inertia of this disk about its center of mass axis is mr square by 2, which is m by 16. Its radius is r by 4 whole square, mr square by 2. Okay, this is the moment of inertia about this small disk about its center of mass axis. Now if I want the moment of inertia about this axis, I'll have to add md square. So plus, so I'm erasing this. So to this we'll need to add plus, mass is m by 16, distance between the axis is 3r by 4, so 3r by 4 the whole square, and this will give you the answer. Okay, 109 is what the answer will be. Okay, going on. Okay, so this question is finding dipole moment about the origin. The charges are given and their coordinates are given. Okay, now Now this question is slightly out of syllabus, right? They want the resultant dipole moment about the origin. Okay, so I'll just mention the formula. The formula for finding the dipole moment is sigma, so qi ri vector. Okay, so the first charge 2q is present at this location, so it is plus 2q times its position vector, which is minus 3a j cap, plus the second charge, which is 3q, times its position vector, which is 2a I cap, and then the third charge is minus 4q times its position vector, which is minus 2a I cap. Okay, this will give you the net dipole moment, but this formula is usually like not covered in class. Okay, it's not even in NCERT, but yeah, this will be this dipole moment formula you can use to find any dipole question's answer. So you must be familiar with this question where we place minus q charge here and some 2q charge here, and I guess another minus q charge here. So this you break it down as two dipoles. You can just use this formula also. Okay, that way also you can get the answer. Okay, so this answer will be the first option. This question was asked in JEE Mains. Okay, this I guess Jan session. Okay, next. A flexible chain of mass m hangs between two fixed points at the same level. Inclination of the chain with the horizontal at the 2 points is 30 degrees. Okay, so this is the chain. They have said this angle is 30 degrees. This angle. Now, this question is a standard question, so we need to find the tension at the lowest point. So just take this FBD over here. So the tension here will be along the x direction. This will be equal to this tension cos 30. So T dash cos 30 is equal to T, and this vertical component T dash sin 30, it will balance the weight of this part, which is actually mg by 2. This will be mg by 2. Now you can take the ratio. Okay, the answer will be, yeah, second option. Okay, next we have a point charge and a thin insulating wire whose charge is given. It is distributed uniformly along its length. This is a charged rod. Okay, that is a point charge. We need to find the force between them. So you will have to use calculus here. So how to do it? So you can go a distance of x from this point. Take an element whose width is dx. Okay, so if the charge of this element is dq, find the force of repulsion between these two charges. It will be kq times dq divided by distance between them squared. So this distance is x, this distance is 2. So x plus 2 the whole square. Now dx you will write it as lambda, I mean dq we can write it as lambda dx, and then you will integrate with respect to x, right? So and the x value varies from x equal to 0 to x equal to 10 to cover the entire rod. So that is this question. The answer will be 90 once you solve it. Okay, L plus A, yeah, that it will have that, yes. This question also you can use that formula to find the equivalent focal length. 1.5, so this part has 1.5, this part has 1.2, and it's placed in air, I guess. So the question is, where is the image formed? Object distance is given as 30 centimeters. Okay, so we'll find the equivalent focal length. We will use the same formula. So here it is 1.5, 1.5, here it is 1, here it is 1.2, here it is 1. So mu on the right minus mu, so 1 by focal length equals mu on the right minus mu on the left divided by radius of curvature. So this side will have a positive radius of curvature. It is equal to 15, so plus 15 plus this surface. We don't have to write anything because it is a flat surface, right? So r will be infinity. The last surface, mu on the right minus mu on the left divided by, so this surface will have a negative radius of curvature and it is minus 12, so this will be minus 12, and this is half divided by 15, so 1 by 30, and this is minus 0.2 divided by minus 12, so this is, I guess, plus 1 by 60, 3 by 60, I guess the focal length will be plus 20 centimeters. Okay, so the equivalent focal length is plus 20 centimeter. This will act like a convex lens whose focal length is 20. Now we can use lens formula, 1 by v minus, object distance is 30, so 1 by minus 30 equals 1 by f. So 1 by v is 1 by 20 minus 1 by 30. So v turns out to be 60 centimeter. Question is magnification. So magnification will be v divided by u minus 2. Okay. How much portion? I guess total slides is 91. Now we are at slide 70. Okay, so 20 something more slides. Nucleus at rest disintegrates into two smaller nuclei with their masses in the ratio 2:1. After disintegration, they will move. So initially the nucleus was at rest. Okay, then it splits in the mass ratio of 2:1. Basically, one piece has 2m mass and the other piece has m mass. Okay, so by momentum conservation, initially momentum was 0, finally also it should be 0, which means if this 2m has a speed v, this mass will have the speed of 2v, right? So the mass ratio, if it is 2:1, speed ratio will be 1:2. So in opposite directions, of course, in the ratio 1:2. First option, yes Om, that is correct. Okay, so next. Square loop of side 15 centimeters is moved towards the right at a constant speed of 2 centimeters per second. The first edge enters the 50 centimeter wide magnetic field at t=0. Okay, so at the start, this edge is at the starting position of the field, and we need to find what is the induced EMF at t=10 seconds. Okay, so initially basically this right edge is over here. So in 10 seconds, speed, if it is 2, distance traveled is 20 centimeters. Okay. So the side length is 15 centimeters. So basically the square will be somewhere over here, where this is 5 centimeters. This is the situation after 10 seconds, right? So if the loop is completely inside, then of course the flux is now constant, flux is not changing, so EMF is 0, right? If the flux is constant, EMF does not change. Okay, so EMF will only be induced until the situation is something like this, where the left loop is still outside. In this case, EMF will be induced, but the moment the loop is completely inside, EMF induced will become 0 because flux becomes constant. Next, 1 kg mass is suspended from the ceiling by a rope of length 4 meter. Horizontal force F is applied at the midpoint of the rope. So that rope makes an angle 45 with respect to vertical axis. Magnitude of this force F is, okay, it will be equal to T sine theta, which is T1 by root 2. Okay, so T2 is equal to 10 Newton. So T1 by root 2 is this vertical force. So T1 by root 2 is equal to 10. This is also T1 by root 2, so F is equal to 10. Okay. Option B, second option. All right. Next, biconvex lens. We have two lenses like this. Focal length is 10 and 15. Distance between L1 and L2. So this light ray, it will fall at. So this distance is of course equal to the focal length of the first lens, which is 10 centimeters. Now if you observe, this light ray after hitting the second lens becomes parallel, which means this distance is the focal length of the second lens, which is equal to 15 centimeters, right? So this point is the focus of this lens. This point is also the focus of this lens. So the distance between the lenses is 25. Okay. The resultant of two vectors A and B is perpendicular to A, and the magnitude is half that of B. The angle between vectors A and B. Okay. So vectors questions, it's useful to draw a triangle diagram first. So we have a vector A and another vector B, and its resultant is perpendicular to A. So if this is my vector A and if this is my vector B, then this is going to be the resultant, and the resultant is perpendicular to A. So this is going to be a right triangle, right? Now it's given that its magnitude is half that of B. So if this side length is small b, this side length is b by 2, right? Because the resultant's magnitude is half that of B. So from here we can find out this angle theta. Sine theta is half, which means theta is 30 degrees. Okay, it's 150, yes. This is the direction of A vector. This is the angle between A vector and B vector, which is 150 degrees. Okay, that is the answer. Next, electric field, which is a non-uniform field, 2x I cap. We have a cube of side 2 meters placed in the space as per given below. Electric flux through the cube. So electric field is only along the x direction. So there will only be non-zero flux through this left face and this right face. The other four faces are perpendicular to the area vector is perpendicular to the electric field, right? So if you choose this plane, the area vector is along the j cap direction, but electric field is only along the I cap direction. So the other four area vectors for these four areas, the area vector and electric field are perpendicular, so the flux would be 0. So we have entering flux through the left face, we have exiting flux through the right face. We just have to find their difference. So for the first area, the area vector will be towards the left, and the electric field is along the x direction. So if you do E dot A, it will be negative. So that initial entering flux will be E into A basically. Electric field is 2x, x coordinate is 2, so electric field will be 4, times the area is 2 meters the side length, so area will be 4. So initial entering flux is minus 16, okay, and the exiting flux, so the x coordinate is 4, so the electric field will become 4 into 2, 8. Area of cross section is once again 4, so this is plus 32. So the net flux is the 32 minus 16, which is 16. Okay, so this would be 16. So that is it. So here the area vector is along the right, and the electric field is also along the right. So the flux would be positive, and here the area vector is to the left, electric field is still to the right, so the flux is negative. So now we add them together. That is the answer. Okay, 32 minus 16, it will be 16. Next, circular disc reaches from top to bottom of an inclined plane of length L. When it slips down the plane, it takes t seconds. When it rolls down the plane, it takes. Okay, we need to compare the sliding time and the rolling time of a circular disc. Okay, so if the disc is simply sliding down, then its acceleration, so let's say the acceleration is a. So the acceleration, if it's just slipping down, is going to be g sine theta if there is no rotation. Okay, and the acceleration of rolling, this formula is g sine theta. Once again, we covered it earlier. It will be g sine theta upon 1 plus I divided by mr square. Okay, so I is half mr square for the disc. So this will be 2 by 3 g sine theta. Okay, so now the time is what we have to compare. For the time, it is simply root of 2L by A. The length of the incline is L. Time is simply root of 2L by A. Okay, so time is root 2L by A. Length L is the same. So T2 by T1 will be root of A1 by A2. You can just take the ratio now. The answer will be 3. Okay, so the answer will be 3. Next question. Monochromatic light of wavelength 500 nanometers is used in YDSE. One of the slits is covered with a very thin glass plate. Central maximum is shifted to a position previously occupied by the fourth bright fringe. The thickness of the glass plate is. Okay. This is another popular type. So we have like the two slits, and in front of one of the slits, we keep a glass slab. So they're saying the central maximum is now shifted. So central maximum is usually the position over here, right? Where the path difference is 0. This position is called the central maximum. Now they're saying the central maximum is shifted to a position over here, which was earlier occupied by the fourth bright fringe. Okay. So first bright fringe is over here. The next one is beta distance above, which is so first bright. So the next is beta. Third it will be at 2 beta. Fourth will be at 3 beta. So this distance is 3 beta, and okay, so if now all you have to do is make the path difference 0. So the glass slab is placed somewhere over here now, right? Now this glass slab will introduce some extra path length. So this wave path, if this wave's path, in this wave we'll have some extra path length, and this wave will travel without any extra path length. So if I say this is L1, this is L2, the extra path length introduced due to this glass slab, it will be equal to this d sine theta. So if this angle is theta, we can say d sine theta is equal to extra path length introduced due to this glass slab which we covered it earlier. It will be the thickness of the glass slab into mu minus 1, T mu minus 1. So that is it. Now the thing is, for sine theta, you can approximate it as tan theta, and we will write it as 3 beta divided by capital D. Okay, so after that we can substitute. Okay, so beta is of course the fringe width. Okay, lambda capital D by small d. So at O we have the central maxima, first maxima, second and third. So this is the first maxima at the central maxima. This is second bright fringe, third bright fringe, fourth bright fringe. This distance is beta, this is another beta, this is another beta. So the fourth bright fringe is at 3 beta distance. Okay, so that is it. Next is the answer. The answer will be 4 micrometer. Okay. Capacitor of reactance 4√3, resistor of resistance 4 are connected in series with a AC source of peak value 8√3 volt. Power dissipation in the circuit. So they are asking the average power. So we saw this formula earlier. It was V0 I0 by 2 cos delta phi. So or cos phi, cos theta basically. Okay, so V0 is 8√3, peak 8√2 is the peak value. For I0, what you can do is you can find the net impedance, right? Capacitive reactance is 4√3. Resistance is 4 ohm. So the net impedance is going to be 4 times square root of 4, which is 2. Net impedance is 8 ohm. Right? Use Pythagoras. Net impedance is 8 ohm. So current value will be V divided by net impedance, which is root 2. Peak value of voltage is 8√2. Peak value of current is V divided by Z, which is root 2, divided by 2 times cos theta. Okay, theta is the phase difference between voltage and current. Okay, so that is basically this angle itself. So cos theta is going to be half. Right, so this will be half. 2 cancels out with this. 2 cancels out with this. The answer is 4 watts. Okay. All right, that is it. The formula based question, average power is V0 I0 by 2 cos theta. V0 and I0 are the peak values. Okay, I0 we can get it by V0 divided by net impedance. 4 ohm is the resistance. This 4√3 is the capacitor's reactance. So the net impedance will be the hypotenuse basically, which is 8 ohm. Cos theta is the power factor, which is this angle. So in this triangle, cos theta is 4 divided by 8, half. Heavy bar of weight W is having its one end on the ground and the other end on the shoulder of a person. So the diagram is something like this. This is the ground. We have a person over here. So one end is on the ground, the other end is on the shoulder of that person. Something like this. The question is, the bar makes an angle theta with the horizontal. For the weight experienced by the person, it should be the force rather than the weight, the force experienced by the person. So basically they are asking, so this guy's shoulder will exert a normal reaction force in this direction. This force is basically what we have to find. Next, so the weight is W. So weight will be acting at the center of mass of this rod downwards. So now we can just do a torque balance about this point. Oh, so W times this distance, which is L by 2 cos theta, equals the torque due to this normal, which is normal into length. So normal into length equals the weight into L by 2 cos theta. Okay. So the answer will be W cos theta divided by 2. W divided by 2 cos theta. That should be the answer. Yeah, so there will be a cos theta in this denominator. So W divided by 2 cos theta. This will be the answer. Okay. All right. Next. Square loop of edge length 2 meter carries a current of 2 amperes. It is placed with its edges parallel to the XY axis. Magnetic field passing through the XY plane and expressed like this. So basically the loop is placed. So this is the Y direction, this is the X direction. The square loop is placed like this. It is carrying a current of 2 amperes net magnetic force. So let's say the current is clockwise. Magnetic field is along the k cap direction, so it is out of the page. The question is, what is the net magnetic force? So this is a current carrying wire in a magnetic field. So we'll have to use the ILB formula, right? So at x equal to 0, if I put x equal to 0 here, the magnetic field is B naught in the k cap. So in this wire everywhere, the magnetic field felt is B naught in the outward direction. So if you do I cross B, B is outwards. So if you do I cross B, it is towards the right. So on this, let's say the force is F1 to the right. This F1 will be ILB. Current I, length of the square is, let's say, L times B naught. This is the force felt by the left one. Similarly, for this one, if you do I cross B, the answer will be towards the left. So this rod will feel a force to the left, and F2 is similarly going to be IL, but the magnetic field here is different. So for that we have to put x equals 2 meters, because this distance is 2 meters. So here to put 2 here, so 4 2s are 8, 8 plus 1 9, so IL times 9 B naught. That is the force to the left. And now due to this wire, let's say the force is F3, so IL cross B will be downwards, let's call it F3, and due to this wire it will be IL cross B, it will be upwards. But due to symmetry, this force F3 and this force F3, they are the same, right? Because of symmetry, they are the same, because you will use the same method to find the magnetic field due to this wire and due to this wire. So those two F3s are equal and opposite, so they cancel out. So the net answer is simply going to be this F2 to the left minus F1 to the right. So F2 is in the left direction, F1 is in the right. So this is greater, so the net force will be towards the left, and the magnitude is I8 IL B naught, okay, towards the left. So this will be the answer. You can substitute it Final answer will be 160. Okay. At the center of a half ring, linear charge density is lambda, potential is. So this is the standard formula. Half ring. What is the potential at the center? So basically all the dq charges are at a distance of r from this point O. So net potential is simply integral of k dq by r. Now because all dq charges are at r distance from O, we can just take it out of the integral. So this will be integral dq, which is basically the total charge. Okay, and total charge will be charge density lambda multiplied by the half circumference of this circle. That is it. The answer for this will be 36, okay, after calculation. Two persons pull a wire towards themselves. Each person exerts a force of 200 Newton on the wire. This is the wire. Person 1 exerts 200 Newton like this, person 2 exerts 200 Newton like this. So because of this stress, the rod will get stretched. So this is the Young's modulus problem. F by A, stress divided by strain, and now it's just substitution. Okay, Young's modulus is given, length of the wire is given, cross sectional area is given. You can find delta L. So substitution problem. Okay. So this question, I mean, the final answer will be 20 micrometers after you solve it. All right. Next is a circuit problem. We need to find this current, right? Current through the 1 ohm resistor. So this current is, you have to find the current in this branch. Okay. So the circuit, we can use nodal method. So we'll just assume one of the points as a reference 0 voltage. So this will be a 5 volt point. This point C, we will assume some voltage V, potential V. And over here, we will assume some V dash. And now we'll have to find V and V dash. Right? So we need two equations to find V and V dash. So firstly, we will write the KCL equation at node C. So V minus 5 divided by 2 plus V minus 0 divided by 2 plus V minus okay, so let's, if this point has voltage V dash, this point will have voltage V dash minus 10, right? So V dash minus V minus this voltage, which is V dash minus 10, V minus V dash minus 10 divided by this resistance, which is 1, equal to 0. So this is the KCL equation at node C. This current plus this current plus this current equal to 0. Net currents coming in equals 0. Now we will write one more equation in this node. So that will be V dash minus 5 divided by 4, that is this current. And then we have V dash. Okay, so this current is just going to be the same current. Okay, so this V dash minus 5 divided by 4. What exactly is this current? This current is going to be this one. Okay. Now, what is this current going to be? This will be V dash minus 10 minus V divided by 1. And the third current will be this one, which is V dash minus 0 by 4. This is equal to 0. So, this current plus this current plus this current equal to 0. KCL at node A. These two will give us two equations in V dash and V. And then you will have to solve for V dash and V. And once you get it, this node has V potential, this node has, this is V dash, this is V. So this current I1 will be the potential difference across this resistor divided by 1. Okay. So that will be the answer. So the answer will be, this is a calculative question, the answer will be 25 ohm, 25 for N. Okay. Long straight wire of radius A carries a steady current I. Current is uniformly distributed across its cross section. Ratio of B at A by 2 and 2A from the axis of the wire. Okay, so this is the current carrying wire. If this is the cross section, first we need a magnetic field at half the radius, which is at A by 2 location, and then we need at 2A location at the magnetic field. So we did this question earlier. All we have to do is apply Ampere's circuital law once. So let's say the current is coming out of the page. So magnetic field will be counterclockwise sense. So what is the enclosed current in this A by 2 cross section? So in the total cross section, the current is I. So I is distributed in pi r square area. The area of this particular cross section is pi A by 2 the whole square. So it's 1/4 the area. So the current enclosed within this loop is I by 4. So integral B dot dl will be B into 2 pi A by 2. This will be equal to mu naught times I enclosed, which is I by 4. So with this we can get the magnetic field at A by 2 radial distance, and for 2A distance, I mean that formula is simply mu naught I by 2 pi distance, right? So the answer will be 1:1, yes, if you take the ratio. Next is the dimensions problem. So this particular quantity epsilon naught E square, so half epsilon naught E square was the energy density due to electric field, right? Energy density's dimension is energy divided by volume, ml square T minus 2 divided by L cube. So the dimension is ml raised to minus 1, T raised to minus 2, first option, okay. All right, this question is a buoyancy question. We have a cube submerged. So it's part of it is submerged in water, part of it is submerged in kerosene oil. The specific gravity is given, which is just the density with respect to water. The question is, what is the ratio of volume of ice submerged in water to that of kerosene oil? Okay, so let's say this is water, this is oil, this is, let's say, the cube. So the net Bowen force in this case, it depends. Okay, so if this submerged volume, if we take it as VW, and if this submerged volume, if we take it as V oil, so the net buoyant force on this is V water, volume submerged in water, times density of water, which we'll take it as rho W, into G, plus volume submerged in oil, density of oil. Density of oil, we'll use this specific gravity formula. Specific gravity of oil is 0.8, so this will be 0.8 times density of water. This will be density of oil into G, and this will be equal to the weight of this cube, which is total volume, density of the cube, which is 0.9 rho W into G. Okay, so now the question is, what is ratio volume of ice immersed in water to that of the oil? So VW divided by V oil is what we have to find. Okay, so V will be V oil plus VW, right? So G cancels out and rho W cancels out. Now we will write it as V oil plus VW, and then it's just rearranging and taking the ratio, right? So that will be option D, the last option. Okay. Now the only step left is this, writing this V as V oil plus VW. That is the only step remaining. Angle of projection for a projectile to have the same horizontal range and maximum height. So R is equal to H basically. So actually there is a relation. If you calculate R by H, that is basically if you divide the range and the maximum height formula, this becomes equal to 4 by tan theta. Okay, so this, some of you may know this. For this, you just need to divide the range formula with the maximum height formula. So if the range and height are equal, then tan theta is 4, or the answer for theta is tan inverse of 4. Okay. Next, circular table with angular, it is rotating. There is a smooth groove along the radial direction of the table. Steel ball is gently placed at a distance of 1 meter on the groove. All the surfaces are smooth. The radius of the table is 3 meters. Then the radial velocity of the ball with respect to the table at the time the ball leaves the table is. So once again we'll use the rotating frame to solve this. So we'll have to apply the centrifugal force, pseudo force. So this ball is over here. And initial distance is at r equal to 1 meter. So let's say at any general instance, this length is x. So the centrifugal force is basically in this direction, and its magnitude is m omega square x. Okay. Now this m omega square x will accelerate this particle along the radial groove. So m omega square x, this is the net force. This is equals to mass times the acceleration along the groove. Okay. So now acceleration, so if this distance is d, I can write the acceleration of the groove as v dv by dx. So this I can write it as v dv by dx, where of course v is the speed along this groove. Okay. We are working in the rotating frame in this question. So the disk is assumed to be at rest. Okay, you can ignore the rotation of the disk. So now what we'll do is we'll integrate. So v dv equals omega square x dx, and now we'll integrate this. So we start from x equal to 1 meter, and finally we want the radial velocity when the ball reaches this point. When it reaches this point, we want this velocity. Okay. and that is x equal to 3 meters. So we need to integrate from x equals 1 to x equals 3. Over here the velocity is 0, radial velocity is 0. Finally we need the radial velocity. So now this is a simple integral, okay. Now if the ground frame speed was asked, then the situation will be some slightly different. Then you will have to find this v using the same process, but to this v you will have to add an omega r as well, right, because the disk is also rotating. So this v is the relative velocity with respect to the disk. To that you have to add the omega r of the end point as well. So when the ball will be ejected from this point, its velocity with respect to disk will be this v, but with respect to ground you have to add the omega r as well, okay. So that is it. In this question only this v is needed because they wanted only the radial velocity, okay. So yeah, after you solve this integral the answer will be 2 for x. LCR circuit has resonance for a capacitor C, inductance L and resistance R. Now the value of resistance is halved, keeping all other parameters same. The current amplitude at resonance will be, so the current at resonance will be the voltage amplitude divided by resistance, right, because in resonance condition the impedance becomes equal to the resistance. So the current amplitude at resonance will be, what is changed, value of resistance is halved. So in the new case it will become R by 2. So the current amplitude becomes 2 times, so doubled. A car of 800 kg is taking turn on banked road of radius 300 meters. The angle of banking is 30 degrees. Coefficient of static friction is 0.2. What is the maximum speed with which the car can negotiate the turn safely? Okay. So here this is the ground. This is, let's say, the banked road. Let's say this is the car. I am replacing the car with just a block. So the radius of the path is actually 300 meters. So we'll take it as R. Okay, so from the top view, this car will do a circular motion, right? This radius is the radius of that circular path. Now once again we will apply centrifugal force on this car. Okay, and that centrifugal force will be in the right direction, right? The center of the circular path is here. So this radius, if this is the center of the circular path, this radius is R. So the centrifugal force is m omega square R. Okay, R is given. R is the radius of this circular path. Now we'll have the weight force acting downwards. Now if we increase the speed of the car, now omega is nothing but v divided by r. If we increase the speed of the car, this centrifugal force will increase and the car will have a tendency to slip along the road in the uphill direction. So to counterbalance that, we'll have the friction force acting downhill. Okay. If we increase the speed, the centrifugal force will try to push the car uphill, and to balance that the friction will act downwards. So in the maximum speed case, the friction will become limiting. Friction will become limiting, which means it will be equal to mu n. Okay. Now it is just a force balance. So along the inclined plane, if this angle is theta, the component of centrifugal force is m omega square r cos theta, and the perpendicular component is m omega square r sin theta, and mg's component is mg cos theta, right? So the net normal force is mg cos theta plus m omega square r sin theta. So friction will be equal to mu into n, right? So mu into n, there will also be the component of mg sin theta downwards, so plus mg sin theta. This will be equal to m omega square r cos theta. Okay, so that is it. Now we'll substitute normal reaction over here and we'll get the answer. So in the maximum speed case, the block will have a tendency to, or the car will have a tendency to slip upwards. Okay. All right. Now all that is left is substitution, and the answer will be this. Okay. So this is the second last question. No, actually, this is the last question. Assuming the Earth to be a sphere of mass density, uniform mass density, body weighed 300 Newton on the surface, what will happen to its weight at a depth of r by 4? Okay. So yeah, guys, just comment down the answer for this and then we'll end the session. So the formula for gravity at any depth d from the surface is gravity at the surface g times 1 minus d by r. So what will be the answer? So the depth will be r by 4. So gravity value is 3/4 of gravity at the surface. So 3 by 4th of 300 Newton. Guess the answer will be 225. Okay. Okay, so that was it, guys. That was all the problems. So all the best for everybody who have exam tomorrow. Okay. Goodbye. Take care. खत्म हो गया बस. हाँ मतलब वो जल्दी हो गया क्वेश्चंस थोड़ा जल्दी डिस्कस हो गया. क्या हुआ सर? मतलब नहीं देखा मतलब ज्यादा नहीं 13 पॉइंट. अच्छा अच्छा. ओके.